Okay, so we're going to start with the notes. So today's notes are going to start us with what's called the unit circle. The unit circle part of Trig is the new part that we're going to be talking about with Trig, because I know you guys have had some experience with Trig in Math 2, but this is where we're going to take it to the next level. And this is going to be the Trig that you're going to need for those of you taking AP Calculus in the fall. So the unit circle. So pretty much the unit circle is a circle, as you can see, the circle. And it's called a unit because it has a radius of 1. So from the center to any edge is 1. That's why it's called the unit. It's 1 unit. Okay? It's got a center at 0, 0. So the center is always going to be for the unit circle. If we're talking about the unit circle, the center will always be at 0, 0. And then 1, 0 is the first point, 0, 1, negative 1, 0, 0, negative 1. Okay? This is the x, we call this the x, and this is the y. So it's kind of mixing a circle with the coordinate axis that you guys have been used to. And also, it also has quadrants. There are 4 quadrants. Top right is 1, top left 2, bottom left, bottom right. So just like a graph, 1, 2, 3, and 4. Today, we're just going to focus on quadrant 1. We're going to focus on that. Once we get a hold of once we understand that, then we're going to move to the rest. Okay. Okay. So quadrant 1. Quadrant 1 looks like this. Okay. So let me label this. This point is 1, 0. This point is 0, 1. Okay. And then we have dots here. Okay. Well, when we think of the unit circle, we think of angles. Where do those angles happen? The angles always start from the center. Angles always start from the center. Okay. So when we think of it, the first angle that we're going to see is this angle here. That angle is 30 degrees. It's 30 degrees. Okay. As radians, 30 degrees is pi over 6. Okay. So what happens is if I draw a line down from the dot to the x-axis, okay, so this angle here is what's called the reference angle from last notes. It's going to make a special type of right triangle. Why is this important? Because it's going to help us figure out the coordinates. What are the coordinates? I know this coordinate right here is 1, 0, and this coordinate up here is 0, 1, and this coordinate in the middle is 0, 0. But what are the coordinates for a 30-degree angle? Well, funny thing is, when I draw this triangle here, it makes a triangle we've worked with before, 30, 60, 90. Okay, theta is the angle in the middle. That's always going to be theta for the unit circle. So in this case, theta is 30 degrees. The angle on the edge is 60, and then of course that's a 90-degree angle. Okay, so I know that this here is 1. That's why I have 1 right there, because it's the radius. Now what I have to figure out is what is the length here, what is the x going to be, how much do I have to go over, and how much do I have to go up? Okay, well, to do that, you're going to use our notes from last time. If you remember, or if you have those notes in your notebook, it's a 30, 60, 90. Okay, so we know that the angle, we know that the angle opposite of 30 is going to be x, or 1x. The angle opposite of 60 is going to be whatever this number was times the square root of 3. And we know the hypotenuse is going to be double what the angle was opposite of 30. Okay, so let's look at this. We know what this is here. We know the hypotenuse is 1. Okay, so if the hypotenuse is 1, that means the angle opposite of 30 is going to be half of that. Well, which one is opposite of 30? This guy right here. Y is opposite of 30. Okay, so let me write this down. So I have x and I have a y. So I know this is 1. I know since this is 30, This is opposite, so it's going to be half of that. So I know y is going to be 1/2. Okay, just using my 30, 60, 90. Okay. From there, I need to know what my x is going to be. How far do I have to go over? If I go up 1/2, how far do I have to go over? Well, there's a couple different ways to do it. We know that y is 1/2. We know that the hypotenuse, or the radius, is 1. So we can use a squared plus b squared equals c squared to figure it out, or we can just use our cheat sheet over here. Well, this is 1/2. This is 1. What is this going to be? Well, it's going to be 1/2 times the square root of 3. Well, what is 1/2 times the square root of 3? Let's see. 1/2 times the square root of 3. Remember, from now on, we are not changing those into decimals. You're leaving it as a square root of 3. Well, this is the square root of 3 over 1. So the square root of 3 over 2. That's going to be x, the square root of 3 over 2. So x is the square root of 3 over 2. Y is 1/2, sorry. And this is always going to be 1. And that's this coordinate right there. So if I want you to get to that x right there, I'm going to tell you go over square root of 3 divided by 2 and up 1/2. Okay. The next one, the next angle is this angle right here in blue. Okay. That angle's a little bit bigger. It's a 45-degree angle, which is the same thing as pi over 4. Okay. So that one's going to look like this right here. If I draw that triangle, that one's going to look just like that guy right there. Okay, so again, this is my theta because it's my center angle. It's the angle from the middle. It's 45 degrees. That's why this guy is 45 degrees. This guy is also 45 degrees because this guy has to be 90. Okay, well, again, we've worked with those. We've said 45, 45, 90 have a special relationship. Okay, so 45, 45, 90 are 45, 45, 90. We said that these two are the same because it's an isosceles triangle. So whatever these two are, they're the same. This guy right here is this, or this, times the square root of 2. Well, the problem is we have this, but I don't have this. So to go from here back, I'm not going to multiply times the square root of 2. I'm going to divide by the square root of 2. Okay, so I'm going to take what I know, my radius is 1, and I'm going to divide that by the square root of 2 to get these guys right here. Okay, well, I can't leave a root in the denominator, so I'm going to rationalize. So I get the square root of 2 over 2 times 2 is the square root of 4, which reduces to the square root of 2 over 2. That is the length of x and the length of x. So this coordinate here, I'm going to go over the square root of 2 and up the square root of 2. So this dot right here is at the square root of 2 over 2, comma the square root of 2 over 2. That's where that dot is right there. That's how I get to that dot. Okay. And then the last angle within the first that we're going to work with is this angle right here, the green one. It's the biggest angle so far. Well, that angle is 60, which is pi over 3. Well, it kind of looks similar to the first angle that we saw. The only difference is it's kind of turned over. So this one right here, the red, look like that. This one here is just rotated. Okay, but it has the same dimensions. It has 30, it has 60, and it has a 90. So guess what? It's also going to have the same exact measurements as 30 when the center angle was 30, except they're just going to be reversed. Okay, so to get to this 30, we said go over the square root of 3 and up 1/2. Now we're just going to reverse that and say go over 1/2, go up the square root of 3 over 2. Same coordinates, just reversed. Because it's the same triangle. It creates the same exact triangle. That's it. Okay. Oh, yeah. And then 0, 1, what angle is that? Well, that's 0 degrees, which is the same thing as 0 pi. And then how about 0, 1? Well, this angle here is 90 degrees, which is the same thing as pi over 2. Okay, so you have each degrees in degrees and in radians, and you also have each of the angle measures. Okay, so that's what your homework will deal with, just within quadrant 1. So I'm going to ask you things like, what is sine of a 45-degree angle? And I don't want decimals. Okay, well, let's go back to that triangle. If you're just getting used to this, I would suggest drawing triangles a lot. It helps. Okay, that's 45. So they want to know what sine of 45 is. Well, sine is opposite. Well, what is this here? Well, this is going to be the square root of 2 over 2. So I'm going to go square root of 2 over 2 over hypotenuse, 1. Well, anything over 1 is just going to be itself. So sine of 45 or pi over 4 is the square root of 2 over 2. Okay, what if they ask you for cosine of 30 degrees? Cosine of 30 degrees. Well, I'm going to use this triangle here, the smaller triangle, since it's 30 degrees. So cosine is adjacent over hypotenuse. So this guy here is a square root of 3 over 2 over 1, which would just be the square root of 3 over 2. So cosine of pi over 6 equals the square root of 3 over 2. Okay. The next assignments I give you will deal with quadrants 2, 3, and 4. Okay, but the first one will just be quadrant 1.